Today we're going to be looking at some probability. We're going to be kind of throwing in some of those combinations and permutations that we've been talking about over the last couple of days. But let's just review some probability basics. So we'll talk about some sample spaces, we'll talk about basic probability, and then we'll get into the combinations and permutations. So the first thing we need to talk about when we're talking about probability is the sample space. So you'll notice that this will definitely look familiar. Some of the notation might be a little bit different, but let's find the sample space for when a six-sided die is tossed. So a sample space is basically, well, what can happen when this event happens? So there are basically six things that can happen. I can roll a die and I can get a one. I can roll a die and get a two. I can roll a die and get a three. So the sample space, we can say, is written as, and I'll use some curly brackets here. So I could get a one, I could get a two, I could get a three, a four, a five, or a six. So that's what my sample space would look like for a six-sided die. Well, let's ramp it up a little bit. So what happens if we want to flip a coin and choose a marble from a bag? So there's basically two things that we can happen when a coin is flipped. So when a coin is flipped, I could either end up with a heads or I could end up with a tails. When I choose a marble from a bag, there are also two things that can happen. I could get a red marble or I could get a blue marble. So I'll label these as R and B. So it's basically asking us, well, what are the possible things that can happen between these events? So the heads, the tails, the red, and the blue. So let's see how I can match these up. So I could have a head with a red marble. So I'll write that as H comma R. I could pair a head with a blue marble. So I'll do the H comma B. I could have a tails. So I could pair up the tails the same way that I paired up the head. So I could have a tail with a red or I could have a tail with a blue. So my sample space is going to be heads red, heads blue, tails red, tails blue. All right, so let's use this sample space to actually calculate some probabilities. So you'll notice that some of these, like I said, will look familiar. The notation's a little bit different. So when we talk about a probability of an event, we say that an event E has N of E equally likely in outcomes, and its sample space S has N of S equally likely outcomes, if I could speak English. Then the probability of event E is given by P of E is equal to N of E divided by N of S. So basically what that is saying here is that this up here in my numerator is the event that's happening, and this down here in my denominator is the sample space. All right, so let's take a look at a basic example. So example 3 is asking us, a card is drawn at random for a standard deck of playing cards. What is the probability that it is an ace? So I'm going to set up my probability equation here. So P of E is equal to N of E divided by N of S. And I have to figure out what's what. So the specific event is saying, what is the probability that I have an ace? So the event is an ace, because that's what I'm looking for. Well, in a standard deck of cards, I know that there are going to be 4 aces. So I'm going to write this out in words first. So I want to know what is the probability that I'm going to draw an ace from the total deck. So there are 4 aces, and my total deck number of cards is 52. So my probability here is just going to be simplified to 1 over 13. And some of the practice problems on the homework are going to give that in a decimal form. So it's going to say round your answers to 4 decimal places. So we'll say this is approximately 0.0769. But if you can write it as an exact answer, I would just leave it like that. All right, so let's bring in some permutations. So in order to access the ATM at the bank to withdraw money, you need to have a 4-digit PIN number. And basically when the bank sends you your debit card, the PIN number is almost automatically generated for you all the time. And we want to know, what is the probability that when the bank chooses your PIN number, there are no repeated digits? All right, so this is going to be, I'll set up my P of E is equal to N of E over N of S. And I'm going to do my work over here just to kind of show you what this means. So I'm going to start with N of S first because that's a little bit easier for me to start with a lot of times. So I'm going to say this is going to be my total or my sample space over here. And I basically want to ask myself, well, what are the total amount of outcomes that I could have? Well, let's think about this for a second. So I have a 4-digit PIN number. And I know that there are 10 possible digits that could fill in each of these blanks. So I could have 0 through 9 here, I could have 0 through 9 here, I could have 0 through 9 here and here. So what that's basically telling me is that my total is really 10 times 10 times 10 times 10. That's the total possible number of things that could happen in this 4-digit PIN number, which is 10,000. So that's my N of S. That's going to go on the bottom. So then I want to know, well, what about this particular event? Well, this particular event is saying that there are no repeated digits in this PIN number. So basically that's giving me, again, my 4-digit PIN number here. It's saying that I have a possibility of starting with 10 numbers, but I can't repeat a number in that next spot. So then that goes down to 9 numbers. So taking out whatever the number was that went here, subtracting that is going to give me 9 numbers to choose from here. And then I can't repeat again, so I have to subtract the 2 that I've already filled in over here. So that's going to be 8. And then I'm going to do the same thing over here. So for my event, this is actually going to end up being 10 times 9 times 8 times 7, which is 5,040. And that is going to be my N of E in my numerator. So the probability that my bank is choosing a PIN number with no repeated digits is going to be 5,040 over 10,000. And I'm going to go ahead and simplify that fraction, which is going to be 63 over 125, which in decimal form is 0.504. So there's my probability. All right, last problem. So Abdul and his sister went snorkeling this summer and took photos of individual fish with their waterproof camera. They printed their favorite 8 photos, 6 of which showed orange fish. If Abdul randomly chooses 5 of the photos to hang in his room, what is the probability that all of them are orange fish? So set up my E of E equal to N of E over N of S. All right, so I will start again with my total because again, that's kind of easiest for me to figure out what my total outcomes are first before I get into the specific event. And this is going to be where our combinations are going to come back in. So it's asking me for my total to choose 5 photos from my set of 8 photos. So what that's telling me is I'm going to be choosing 8 photos of my 5. So using our combination formula, I'm going to set up my n factorial over my 5 factorial times the 8 minus 5 factorial. I'm going to go ahead and simplify this before I actually go and use my probability formula over here. So that gives me 8 factorial over 5 factorial times 3 factorial. So I'll just kind of expand out that numerator until I can get something that's going to cancel with my denominator. So I can stop at 5 factorial over here. So my 5 factorials are going to end up going away. That's going to leave me with 8 times 7 times 6 in the numerator, and then 3 times 2 times 1 in the denominator, which gives me 336 divided by 6. And when you divide that, that will give us a total N of S of 56. So I'll put that over there in my probability formula. So then I want to know, well, what's happening in this specific event? So Abdul is randomly choosing 5 of the photos. What is the probability that all of them are of orange fish? So here's my event. So my event is saying I'm choosing 5 photos, but this time I'm not choosing from the set of 8. I'm actually choosing from the set of 6 that particularly showed orange fish. So this time my combination is going to be I'm choosing 5 of 6. So I'll set up my factorials here. So 6 factorial over 5 factorial times 6 minus 5 factorial. Simplify that. That'll give me 6 factorial over 5 factorial. This 6 minus 5 factorial is just 1 factorial, which is just 1. So I'm not going to include it over here. So I'll just go ahead and expand that out. So 6 times 5 factorial over 5 factorial. Those cancel out. My event is 6. So I'll go ahead and put that in my numerator over here. So my probability is 6 over 56, which I can simplify to 3 over 28. And in decimal form, that would be approximately 0.1071. All right, so if you have any questions on the homework or anything, please let us know.